Here, a box with open top is to be constructed from the rectangle piece of cardboard with a dimension 20 by 30 by cutting squares at the corners. So let's consider three figures with different x values. Now suppose if x is the side of the square, then height of the box will be x and length will be 30 minus 2x and breadth will be 20 minus 2x. Therefore, the volume of the box will be length into breadth into height. So this is nothing but 30 minus 2x into 20 minus 2x into x. So this is nothing but, if you take 2 common from each of the brackets, so you'll get 4 into x minus 15 into x minus 10 into x. So this is nothing but 4 into x cube minus 25x square plus 150x. Therefore, the volume of the box is nothing but 4 into x cube minus 25x square plus 150x. Now, for the figure 1, x value is 1. This implies volume is equal to 4 times, in place of x substitute 1. So you'll get 4 times 126, which is nothing but 504. In figure 2, so if you substitute x is equal to 2 in the volume function, you'll be getting 4 into 208, which is nothing but 832. For figure 3, the value of x is 3. So volume becomes 4 into, so in place of x substitute 3, so you'll get 252. So 4 into 252, which is 1008. So a clear observation here is the value of x increasing, the volume of the box is also increasing. At certain stage, it will attain its maximum volume. So for what value of x, the volume of this box will be maximum? That is what we are going to find out here. Let us find the maximum value of the volume function. So v of x is 4 times x cube minus 25x square plus 150x. So dv by dx. So we are finding the first derivative, which is 4 times 3x square minus 50x plus 150. d square v by dx square, that is the second derivative, which is 4 times 6x minus 50. Now dv by dx is equal to 0. So critical points we are trying to find out where maxima minima attains. 3x square minus 50x plus 150 is equal to 0. Solving this, will be getting x value as 50 plus root 700 by 6, 50 minus root 700 by 6. But if you see the first value, root of 700 is more than 25. Since x value is greater than 10, which is not allowed as the breadth of the sheet is 20, this value of x is omitted. Therefore, the value of x is 50 minus root of 700 by 6. Also, for value of x 50 minus root 700 by 6, we can see that the second derivative d square v by dx square is negative. Hence, the volume of the box will be maximum for this value of x. Therefore, x is equal to 50 minus 26.45, approximate value we are taking, by 6, which is nothing but 3.92. So approximate value of x is 3.92 inches. Should be the side of the square which you are cutting at the corners in order to get the maximum volume of the box. Let us try to understand this graphically. So along x-axis is the side of the square which is cut, and along y-axis is the volume. So as x increases, you can see that the volume is also increasing, and slowly it becomes 504 if x is 1. And as you increase the value of x further, so as x becomes 2, volume becomes 832. Similarly, if x becomes 3, the volume becomes 1008. And finally, for some value of x, it reaches its maximum. That is, if x is 3.92, the maximum volume is 1056. As x becomes more, and you can see that the volume becomes smaller. If x is close to 7, volume is around 300, and so on. So finally, if x becomes 10, the volume becomes 0.